Greetings, everyone. It has been way too long since I've delivered a weekly science fun fact for you. So I decided it's time to get back in the habit and just deliver some new fun content for everyone. So one disclaimer before we get back into this. For those of you who are watching this, I really want to thank you. I'm glad that you enjoy these. These are a little bit of extra work, and I'm glad that you guys get something out of this. You just get to learn something new. Second comment I want to make is that I know it's very tempting to talk about the coronavirus and COVID-19 right now, and I am making an active decision not to. I want these to be a bit more fun stuff, and yes, there is a lot of great science to talk about with the spread of diseases. Hell, we can do an entire course on just the mathematics of disease spread. And I'm making an active decision not to discuss those things, not because it's bad science, but I think you guys have a lot of resources for that now, and it's time for other strange science. So with that, let's delve into our weekly science fun fact. And we're going to discuss the challenges to making a lunar base. This is based off a paper that I just read a few days ago. And I want to go through one of the key components that's going to be stickler for us. So one of the things is that lunar day is about 29 Earth days long. Remember, the moon's tidally locked to the Earth. And one challenge we got to think about is, well, look at the difference in temperature. On the day side of moon, it's about 127 degrees Celsius. And on the night side, about minus 173 degrees Celsius. So you're going to have for about a month where you're at either very hot or very cold just because of the amount of sun exposure. And you can talk about other issues of like the lack of atmosphere and protection, but let's talk about a material science perspective. It is very expensive to get materials there. Heck, just to get something in orbit around Earth, it's about $10,000 a pound. Just to put 1 pound of material in orbit, it's about $10,000. But this is a challenge worth tackling. We should try to expand into the cosmos. So, if it's expensive to get material there, let's use material sciences. Let's use the resources on the moon. Perfect example of this. There's lunar ice. So why don't we harvest the lunar ice? Not just for our consumption of water, but to water plants, to drive whatever chemical reactions we need. On top of that, why don't we use the lunar surface to construct an infrastructure? And this is where this recent paper is starting to come in. This is a 3D printer creating a sort of concrete. Specifically, this was called a geopolymer. And they're using artificial lunar dust and another component that I'm not going to reveal yet. So, put it in this perspective. We're trying to effectively 3D print a concrete-like substance. And once you can create concrete, you can create infrastructure. Build your base, build a road if we'll eventually need that. And when it comes to concrete, there are 3 main components. You got yourself your water. Boom, we got that. We've got water on the moon. You're out your rock and sand. Perfect. You just scoop up some lunar soil. Good to go. And then you need a binding agent. A cement. And let that dry out so that it comes together in one piece. Well, from a recent paper in the Journal of Cleaner Production, what they decided to try was the utilization of urea. Yes, urea. The primary component in our waste. The idea is that you let the urea be the binder and 3D print that to get yourself your concrete on the moon. Hey, if there's going to be humans on the moon, there's going to be a lot of waste products lying around. So with that, I'll call it a night here. I hope you all enjoy these Return to the Weekly Science Fun Facts, and I'll see you all next week.